Welcome to Module 5 on UHPC-based ABC solutions. We're pleased to welcome our speaker, Atorod Azizinamini, professor in the Department of Civil and Environmental Engineering at Florida International University and director of the ABC UTC. Atorod?
Thank you. And in this module, I guess you have heard about how to develop a UHPC mix. We have heard about the corrosion properties, and we have heard what you can do with the UHPC. Now, in this module, what I'm going to do is I'm going to show you some of the applications of the UHPC. Now, these are some of the work that I have done. At the end of the presentation, I have a list of the list of publications that I will provide you for further references. But please feel free to contact me if you're interested in any single one of those projects or you need more information. I'm going to go through number of application, therefore it will be almost like a table of content, and I'm going to just go over some of the high points and some of the major lessons that we have learned. I won't elaborate on more on the durability, just to see on this left hand side, if you notice over here, all this graph is saying that if I provide let's say, for example, a 3-inch cover, for example, for the retrofit, I can increase, basically, it will take about more than 50 years for the chloride to ingress, whereas for the same thickness of the normal strip concrete will be about 6 years. Now, these are granted using a error solution to the fixed second law, some assumptions in there, but nevertheless, it takes a very long time for a chloride to ingress through the UHPC. We have also, I just wanted to mention this, we have developed a new test method to study the durability of the concrete. Basically what it is, we subject basically, let's say, the surface of a concrete to a very high water pressure in order of the 200 psi pressure. And this on this side, you see a normal stone concrete cylinder, and after 10 minutes, the water ingress about a couple of inches, at least 1 inch through the basic the cylinder. The UHPC almost none after 30 minutes. Qualitatively, basically, just to show you that. The best application of the UHPC probably is going to be in the retrofit, rather than building the whole entire structures using a UHPC. Strategically using a UHPC in a certain area that's really advantageous with respect to durability, such as repair of the columns. One thing that I'm gonna add is that really, compared to all repair techniques, I would make a statement that the UHPC is probably the best option that you have. Every method have its positives and some negatives, but the UHPC retrofitting with UHPC has been done for more than 20 years in Europe. The photos that you see over here are taken from the Switzerland. I visited my good friend, Dr. Broheider in Switzerland, and they've been doing this retrofit for a number of the years. So it's not something that is we don't have any data. There's a lot of experience, and there are structures that have been retrofitted for, and they have been in service for a long time. So the reason I mentioned that is because if you talk to our corrosion folks, you can always come up with questions, but the fact is that, I mean, there are structures in place, and all the evidences that we have seen indicates that the UHPC has a extremely good property when it comes to durability. We've done lots of experiments. One of the experiments that we did, we took let's say, for example, if you have a beam, we took a T-beam, and we said, okay, if I add some steel reinforcement and then add a UHPC, just wrap it with the UHPC, what can I do? The the moment curvature type analysis told me that I can go from this, from here basically, something that is damaged all the way to here. So we said, let's do the study, but more than anything else, since we are going to be basically placing this very thin layer of the UHPC around the concrete, I want to see how it flows. So we took a T-beam, we sandblasted, and we built a epoxy glass formworks. Actually, we placed it in the this T-beam, and then we poured here this. Once we casted the T-beam, which represented the damaged T-beam, we placed it in epoxy formworks. And before putting there, actually, we wrapped it for 24 hours with a wet burlap, because you have to have exposed aggregate, you have to have a wet surface, and then we placed it in the basically glass formworks. And here is and I'm going to show you basically we pour the UHPC, and I'm going to show you how fluid this thing was flowing. This is about 1 inch. There was no, after the test, there was no honeycomb or anything, because you don't have a coarse aggregate. It's very simple. And here it is. You see how it's flowing very easily. In fact, we were using two UHPC mixer, but one of them broke down. So it took us 6 hours actually to fill this thing. But nevertheless, even then, we didn't have any cold joints or anything. So this is the specimen. We actually had it. Kingsley Law did lots of corrosion study trying to see that, for example, in if we can get some information with respect to the durability, and everything was pointed to the fact that the wrapping this T-beam with the UHPC really chokes the system. It doesn't let the oxygen and basically the moisture at the same time to be there, and it chokes the system. In fact, reduces the corrosion rate. We let it actually, the specimen, sit about 2 years in the lab. We were interested trying to see after 2 years how much bonding between this layer of UHPC and the existing beam there is. We subjected the beam to 3 million cycles of cyclic loading at a very high stress level, and then we tested to basically the collapse. The performance was excellent. I don't have all the detailed information. There is a paper that we have submitted for publication on this. We did get the distributed cracks, very large deflection, and basically here is a load deflection. What you are seeing over here is basically the rupture of the first layer of the reinforcement close to the bottom surface, and then the next one, and so on. So this was a load deflection, basically response of the beam. And we have also looked at the use of the UHPC for the retrofitting the beams. And I'm going to just give you some highlights from that study. There are, of course, number of the way trying to repair beams using for example, the damage area. Number of the ways from the FRP, from wrapping with the reinforcement, and so on. So in this case, we did a bunch of testing. We did look at, this was about 5-6 years ago actually. We said, okay, if this is a damaged region, we're going to try to expose aggregate. We're going to put some, basically, develop a composite action through the mechanical action. We actually drilled and put a very short segment of the number 3 bars in there. We had a shell being 75-inch with a nail, 75-inch basically shell that had to be placed with lots of nails. Deeper, basically going a little bit deeper, removing more concrete and exposing the reinforcement, 1.5 inch or 2 inch. I can tell you this. This is a very major lesson. Of course, we always we use the sandblasting and we prepare the surface. Anywhere you put UHPC, you really force the damage to be outside that, unless you put a very thin layer. But if you put any, let's say 1.5 inch in these beams, 1 inch, 75-inch, 0.75, or even 1.5 inch, the damage is going to move away from it. And I'm going to elaborate the idea of the plastic hinge that John mentioned and what the solution could be. But here, certainly anywhere you use UHPC, expect that the damage is going to be shifting from there to somewhere else. And of course, the strength really increases significantly too. Retrofitting columns. Here you can see that, for example, we don't advocate, let's say, for example, if I have a column and I have a corrosive, corroded bars, we don't advocate cutting bars because you may jeopardize the capacity. Always add. But here we are saying, in the diagram, we are showing that cutting and adding. And then the other thing is that based on the discussion that I have had with our European friends, is that really you don't need to remove all the contaminated concrete. As long as you go 1 inch beyond the reinforcement, that UHPC is going to protect the reinforcement from both sides. We've done lots of tests simulating damage, symmetrical, unsymmetrical damage. Here it is, some of the test specimen. And this is our way of forming and then trying to put the UHPC in the damage area. Then we subjected these columns to the axial load and the cyclic lateral loads. One big lesson. First of all, as I said, anywhere you put this UHPC, you are going to shift the damage away from it. The other thing is that if I have a column and I retrofit with a UHPC, be careful with the foundation because the failure can be in the foundation. If you retrofit a column, you also have to retrofit at least put an inch or so layer in the foundation level, because otherwise the damage is going to go into your foundation. Here is we learned by mistake. Here we saw that damage was in the support actually. Then we placed the UHPC in the support, and then good enough the damage shifted to the above where the UHPC was located. We have also these are very recent. We are retrofitting columns. For example, here you see a column that represents here it is a column, existing column, and we are adding some additional reinforcement, and then we are going to wrap it with both normal strength concrete and in one specimen we are going to use a normal strength concrete to basically increase the dimension of the column. Another one using the UHPC. So this is going to be a very interesting test, but it's coming. We've got several specimens that is geared toward the strengthening existing columns by adding additional reinforcement and wrapping them with the UHPC. Timber piles. We have also done work in the area of the retrofitting the timber piles. I can tell you that one of the big lessons that we learned is that because of the moisture variation in the timber pile can cause, let's say, for example, if this is the timber pile is dry and then you wrapped it with the UHPC and then it's wet, it's going to increase in dimension and it can create the basically hoop tensile stress and then cause a cracking. The way we got around that issue was that before we cast the UHPC, we placed a very thin layer of foam, so it's kind of separated the timber pile from the UHPC, and that solved the problem. We have tested many specimens, but these are some of the other specimens that are ready for testing. So this is just a regular test specimen, and this is wrapped with the UHPC. Now, if you have a timber piles, needs to be retrofitted in your estate or in your agency, please contact me. This is ready for the field implementation. Another area that I feel really is going to make a quite significant impact in the way we do basically repair is going to be the shotcrete or the pneumatic applications. And we started this work a couple of years ago, and it has advanced. Now we have modified our non-proprietary ABC UTC mix so that it can be applied to the shotcrete successfully. It took us a time, but I think even with improved equipment that we can purchase, even the method is going to be much more easier and user-friendly to use. So you need the air pumps and this is a nozzle. I mean, we have our own nozzles too. So here is you can see basically here is another one slide, as you see, the example, the shotcrete. Again, with it improve, if I use a pump that has a double cylinders, I can go faster. But even that, with a very primitive equipment, we are able to shotcrete the UHPC. This UHPC has a fiber, 2% fiber, so we are not eliminating. So it is going through. Took us a time to solve the problem of the clogging of the fibers and so on in the hose and all that. We have developed a machine. This is a drawing, but we have not built it yet because of the cost. So the idea here is that basically you send this robot inside and you spray the basically UHPC. This for concrete pipe or steel pipe, especially if you have a corroded steel pipe. Basically, this could be a very good application. Again, we have not built this, but we have designed it, so it's ready to be built. But because of the expense, really, we have not built this one yet. Connections. Here is a connection, basically, that the way you bring the two precast element, and then you cast it. Basically, you connect it with the UHPC. Dr. Stanton, actually, previous presentation gave one solution where for formation of the plastic hinge. In my opinion, I think UHPC needs to be used for moving the plastic hinge away from somewhere. So another way, if I connect these two elements, plastic hinge is going to form over here because nothing is going to happen there. There's another idea that I will show you. Another idea, the neat idea, but this is not easy to do. If you want to know exactly where your plastic hinge is, confine it between the two layers of the UHPC. And we've done some tests like that. I think this is the best one. Basically connect the elements with the layer of the UHPC, and the plastic hinge is going to be right above that, basically. But this is feasible too. If you confine it, a normal slab concrete between two layers of UHPC, you are bound to have the plastic hinge right there. Another area that we have worked, if you are interested, how to connect concrete filled steel tube to basically foundations. So the best detail that we have is actually embed the CFT, which is a CFT basically in the foundation, equal to half the diameter of the steel tube. So if you just embed steel tube, half the diameter of the tube inside the foundation, and then have this reinforcement come up like this, then you will be able to develop basically this type of failure that we have seen in the CFT. I did lots of work in the CFT back in the US-Japan cooperative earthquake engineering work, and these are a typical damage you will see with the CFT when the plastic hinge forms. And that detail that I showed you is capable of doing that. This is not a bridge, but I just wanted to say how fantastic this UHPC is with respect what kind of possibilities. We have actually designed a 42-story building using a UHPC. So if you are interested, I can tell you it quite adds to the economy of the high-rise building, actually. Another application of the UHPC, some of you are familiar with simple for dead load and continuous for live load. The detail over the pier to connect the girders can be a little bit more congested, and we have done numerical work and but not experiment. And our results shows that by using a UHPC, you can significantly reduce that and make this simple for dead load and continuous for live load very attractive. This is probably one of the major one that I really love, and that is prefabricated barrier. This is not the final detail, and I don't have a slide to show you the final detail, but connecting the vertical element, prefabricated barrier, to the deck using a UHPC is fantastic. It just happened just yesterday. We tested this one specimen that's a 15 feet long. We did the edge loading. According to AASHTO, we need to go to 80 kips. This specimen was able to give us 93, just 90 kips. So more than 80 kips. I can tell you this is how we connected the vertical element to the horizontal with the UHPC. I can tell you that those of you who are familiar with the barrier design, using and just connecting this cast in place, you will not get more than 70 kips. The only way to go more than 70 kips and reach what AASHTO predicts is using a UHPC. This was just a test that was conducted yesterday, and we hope to share more results on this. This is at the unloading edge. This is at the loading edge. Basically, this is what we see. No damage to UHPC area, every damage basically outside that. This was a load deflection curve. We reached about 90 kips. Another idea that we have worked is basically having a shell of the element, bring it to the side, placing the steel inside, fill it with the concrete. What you see over here is a 3D printed beam, 12 feet long. So you can put the steel reinforcement in there and go on with it. We have our own special nozzle that we use. So here is, for example, a column shell. This is a animation that says how they're using a robot, you can print it, basically. And I just wanted to show you, this is actually printed section. This is a model. In the next couple of months, we are going to go print a very large scale. This is a smaller scale, but this is a printer that we use to print a shell. So you take a shell, you take it to the field, and then you attach the elements together. This is another idea that we have tested for short span bridge, let's say 20, 30, 40 feet long, short span. These are the modules that you can print, put them side by side, fill it with the concrete, you're done. And these are the, I think about 30 feet long specimen that we have built, but we are going to be printing these sections fairly soon. So 3D printing is another trending area, and we are using UHPC as a material for 3D printing. I want to leave some time for question. I don't know, Mary Lou, how much time do I have?
You have about 7 minutes.
7 minutes. Okay, so I'll be 2 minutes, and then I'm going to try to provide some time for answer question. Very recently, I just wanted to say that our activities in the UHPC area is expanding. Just last week, we got a major the funding from the U.S. Army Corps trying to continue this UHPC, which is going to in the 3D printing, which is going to also help the bridge industry. I'm going to, you have the PDF file of this presentation. These are copies of some of the recent publications that my graduate students and I've had related to some of the material. Some of the latest ones, especially with 3D printing, we have not really published it. So that concludes my presentation, Mary Lou.
Okay, well, thank you, Atorod. We'll now begin the Q&A session. Paul?
Okay, thank you, Mary Lou. Really interesting, Atorod. A lot of things to think about. We do have a few questions. The first one I have here is, can UHPC overlays be used for retrofitting an existing bridge deck?
Yes, there has been number of applications of using a UHPC for strengthening the deck, and it is actually proving to be very advantageous with respect to long span bridge. Yes, there is there has been several applications in recent times.
Okay, how do you account for the leveling of the deck if the deck's got a crown on it? How are you going to do that? Just curious.
You can add some admixtures. You can go out actually up to 7% slope. The work that I've seen, but I mean, you usually need only 2%. I mean, slope, but you can go all the way with adding an admixture, trying to hold basically the mix up to 7% actually. The numbers I have seen from the Switzerland and some of the work that FHW has done too.
Okay, and then do you have to get underneath the top matter rebar? Do you have to remove anything, or are they just maybe the damaged area? Any thoughts?
Yes, there is actually I was discussing with with our colleagues in the Switzerland, and their opinion is that you only need to go. you don't need to even remove all the contaminated concrete. That was the point I was making, that you only need to go 1 inch beyond the reinforcement. And then in addition to that, I mean, you have to add some, if you want to strengthen it, you can add some additional reinforcement. So you can, with the water pressure or the sandblast, you can remove the reinforcement, go below the where the first layer of the reinforcement is. But you don't have to go too much beyond that, because even if you have in the case of the column, for example, if you have a contaminated concrete way beyond that, the recommendation that I heard from the European was that just to remove up to about no more than 1 inch beyond the steel reinforcement you have.
Okay. Then another question, how this came in beforehand, how does the UHPC work and bond with the existing concrete that's in place?
Yeah, there has been lots of work in that. I mean, the best approach is to have an exposed aggregate. If you have an exposed aggregate and you make sure that the surface, the existing normal strength concrete is wet, then you will get a perfect bonding. That moisturizing the normal strength concrete, it's not like, for example, 1 hour before the placing the UHPC to go and spray the water. You have to, with the wet burlap or so, maybe 24 hours before placing the UHPC, you gotta prepare the surface, because there's not that much water in that UHPC, and it's gonna soak and it can cause a cracking. Now, another problem that really we have not addressed, we are working on that, is the placement of the UHP normal strength concrete against the UHPC, or UHPC against the UHPC. That's totally different problem than placing the UHPC against the normal strength concrete. The most practical problem we are dealing with the placing the UHPC against the normal strength concrete. That's where if you get an exposed aggregate, if you make sure that the surface is wet, then you'll be just fine. All the test results indicates the interface stays perfect, and the failure is outside the interface.
Okay. Another one that came in earlier was, is pumping UHPC possible for repair cases in confined space? You had that one where you were doing it in the culvert. That was pretty confined.
Yeah, we actually, I mean, I can tell you that for the shotcrete, I mean, we are doing basically the pumping the concrete, pumping it, and then spraying it with the air, basically, and it works. And we looked at basically the dispersions of the fiber. These were using exactly the same fibers that we've used in the non-proprietary UHPC, very high tensile strength, and everything. The trick was that, in our case, was that we had to prime the line, basically using a mortar. So we would place basically in the pump just a regular mortar that flows very easily, and then UHPC right behind that. Once the pipe was filled out, basically the flow would start to go, the static friction and all that is gone. Then you would have basically or really maybe the inside the hose is wet, and then you have the UHPC, and we haven't had any problem with that.
Okay, we have a few new questions that have come in. The first one was the precast barrier connection. Is that MASH tested, or is it going to be? To what level? Also?
That's an interesting level. That detail, actually, there is an NCHRP projects that hopefully will be starting soon. This was the ABC UTC sponsored actual project. That detail that I showed is not MASH tested. It's this is a static testing, and the excellent question that was asked, actually. The relation between the static test and the MASH test is $1 million question that nobody knows the answer, but it's a good indication. If you do a static test and everything works, and the yield line pattern forms, and you get more than 80 kips capacity for basically the TL5, then that means that if you do a MASH test, most likely you're going to pass that.
Okay. Then new question, have the 3D printed piers been used in any project yet, or just lab testing?
No, we are looking for, if you are interested, we are looking for, in fact, I had one slide, I don't know, maybe I didn't put in there, but there are lots of UHPC based solution that we have. If there is we always look for industrial partners to team up. And if there's an agency that, for example, has an application, let us know. Many of our products at ABC UTC are already basically, in addition to what I showed, I mean, we have some other products that are ready. So let us know. But no, it hasn't been used. It's a fantastic idea to be applied.
Okay. Then what is the expected cost of the 3D printing?
Expected costs. I don't have the exact number, but can you imagine 24 hours a day, no overtime, no health insurance, no union? So look at the total cost. I mean, don't look at the initial cost. And then the other thing actually is that early on with the 3D printing, there was an idea of how do you replace the workers? Well, the fact of the life is the construction industry right now is looking for workers. It's very difficult to find people. So I think it's going to be a hybrid. At the end of the day, we are going to have a hybrid solution where just like a steel mills that you will see 10 people running a whole steel mill. The same thing, I think the construction industry is moving in that direction.
Okay. There's a question here about, and I don't know if this is the 3D printing or your overlays. How would it work on the underside of a bridge deck?
Shotcrete.
Will it stick?
Yes, it does. We are doing a test based on upside down vertical wall. The one that I showed you was a vertical, basically.
Yes.
It's concrete. When you shoot it, basically at the speed, it sticks. We use the VMA, viscous modified agent, basically to modify the viscosity of the mix. And that's what I said. That took us about a year to how to modify the mix so that it sticks to the surface.
Okay, and that's you said the jet skis were damaging the bridges in Florida.
Yeah, the down below,
the bottom of the deck.
Yeah. The jet ski, they spray these. So you have to, when you repair the decks, you have to repair from the top and the bottom, both sides.
Okay, interesting question. We're gonna, let's see. How does it work for deck slab extensions when removing the existing joints?
Deck slab extension, you mean widening?
Well, yeah, or just when you're replacing a joint, maybe.
If you cast in a UHPC against a normal strength concrete, if you have a exposed aggregate and you wet, you have a perfect bonding. It's not a problem.
I guess he was saying if you remove the joints, okay, so, and then you replace it, okay. That's most of the questions we have. I'll ask Don if we got any questions during the question and answers.
Hey, Paul, looks like you got most of them. I'm just scanning through. Well, I'll ask this. So how does it work in exposure to salt and snow or extreme temperatures?
As far as the snow, actually, this is I think the use of the UHPC, like the data that we have shown throughout this presentation, it's a very dense material. And because it has it's a dense and the rapid colloid permeability numbers that we are looking at is in order of the 10, 20, 50 coulomb. So nothing really penetrates. So that's why I think for the bridge deck overlays, for example, the UHPC is a fantastic solution because you're going to seal it up. You're going to add to the strength as well. So it's a durability and the strength. So it's a good solution for the areas where you expect very harsh condition. I did see one very interesting example when I was in Switzerland. They had these almost like a pool. The liner was just with the UHPC, and they were keeping a very hazardous material. So I mean that you can't go any worse than that. So and that that particular structure apparently was in service for some time.
Okay. Well, great presentation, Atorod. Again, great discussion. So Mayor Lou, up to the last but not least presentation.
Okay, Atorod, before you get off, I don't know if this is, I just noticed, thank you, Ollie, a couple of questions that came into emails, and I don't know if they've been addressed. Do the steel fibers corrode in UHPC, and do de-icing salts damage the fibers?
Okay, the material, okay, it's very dense, right? So you are going to get some fibers that's going to be sticking out. Those fibers is going to, at the surface, they get corroded, but it just stays there. That's it. But then even there has been some solution. Probably Ben Grable can give you a little more information on that. The other thing that in one of the presentations, there was a question that was asked, is fibers, if they are oriented in a right, yes, if the fibers are all connected together, all straight, I mean, what is the chance of that? Is zero, probably. But so this hypothetical scenarios doesn't exist. For the practical conditions, these fibers, all the durability test data that's out there shows that what you have in the very, very exposed surface, you get a little bit of a corrosion, and that's it. But it doesn't go any further down. And nothing penetrates through this, basically. I don't know if does that answer the question, Melu? Is that what you asked?
Well, the two questions were, do the steel fibers corrode in UHPC, and do de-icing salts damage the fibers?
No, because it doesn't penetrate. It doesn't penetrate through it.
Okay.
If it penetrates, then it does, but it doesn't penetrate through it because the RCP number that we are looking at is like a 15, 20 coulomb. But the fibers that are at the top that are exposed, yes, they do, but that stays at the top. That's it. Nothing more than that. Ben Grable probably can give you a little more info on that because I know that he did some work on this area.
Okay. Okay, and then Paul, were there any other questions that Atorod might answer? We have a couple of minutes only here before we start up with the last module.
I can give my time to Ben Grable. Probably he can add if Ben is up. Maybe Ben, are you?
Well, there's a question that just came in. Does it work as a wearing surface of the deck?
That's the overlay, I think.
Oh, okay.
Is Ben is done quite a bit of work in the overlay for the deck. Yeah, Ben. There you go.
Okay, and then we'll introduce your module.
Sure, I'll just jump in a little early. Yeah, we've done a good bit of work on overlays. We're promoting that through the Everyday Counts initiative. States around the country are trying this out. So yes, it can be used as a riding surface. The primary purpose is to rehabilitate deteriorated bridge decks. So you take off 1.5 inches or so of your old bridge deck and the contaminated concrete that is that 1.5 inches, and you put back you might call it an armoring layer of UHPC, and it armors it. It provides you a very good riding surface, but it also protects the deck, so you get a good long service life.
Ben, could you elaborate on the very top fibers that are exposed? They get corroded, but nothing more than that. Can you elaborate on that, because there's a concern with that?
Right. Yeah. What we've seen is that if you have exposed fibers, these fibers are made of steel, and that they'll corrode. But the corrosion doesn't progress down into the body of the UHPC. So, if you're placing an overlay on a deck, that you're probably going to have to prepare that surface somehow. You might scarify it or do some sort of grind on the surface. That will leave some fibers. Those fibers will corrode, they will stain, the top of your deck may turn a little brown, but the corrosion doesn't progress into the UHPC and cause distress in the actual material. It's just an aesthetic staining.
All right. Thank you very much. Thank you, Atorod, and thank you, Ben, for joining the Q&A for Module 5. And thank you, Paul and Don, for moderating.